Welcome to our session here at Google Cloud Next. I'm excited to be here with Albert from Nuro to talk about how Nuro uses Google Cloud infrastructure for AI. I'm Brian Schwartz from the product management team here at Google, and Albert is joining me, and he's the head of software at Nuro, and we're going to talk a little bit about what their company does and what role he plays in it. Before we do that, let's summarize the overall agenda for our session today. First, we're going to talk about Nuro, the company, and what they're doing. It's a really interesting use case at the leading edge of AI and robotics. It's a real sneak peek into the future, actually. And we'll obviously spend a little bit more time to learn what Albert does there. Next, we're going to dive really into the tech and talk about what are the challenges when you're at the leading edge of AI and robotics and using cloud infrastructure. Next, we'll talk a little bit about how Google Cloud plays a role in addressing some of those challenges. And last is my favorite section, which is, Albert's got some real lessons learned and some wisdom and knowledge that he's gained, putting the stuff into production and building it and using it. And it's always great to hear from real practitioners. And I'm super excited to hear that knowledge. So now let's hop into who is Nuro. Albert, why don't you talk a little bit about what Nuro, the company, does?
Yes, happy to. And thanks for the intro, Brian. Nuro is a startup in the San Francisco Bay Area. Our larger mission is to better everyday life through robotics. That might sound a little abstract, but our first product is a autonomous last mile delivery service using a custom designed vehicle that you can see on those photos on the slide right now.
And it's interesting. So it's a autonomous vehicle. It's also kind of a robot. And I think you had mentioned when we were prepping for this that there's going to be a service that you're running as well. So do you want to make a quick comment about kind of the nature of the company and the integration of it?
Yes. So even though we're a robotics company, we are not trying to sell this robot to anyone. Instead, our goal is to operate a service. Think of it as transportation as a service, where we work with retailers to provide them an option to have last mile delivery to their customers in the local neighborhood around the store.
It's great. And I can really see how this could be really interesting. Can you talk a little bit about what your role is at Nuro?
Yes, I lead our overall software team. So I'm both responsible for our general software architecture and strategy, but even more importantly, for making sure that the software team is happy and for continuing to grow the team by hiring the best people we can find.
Awesome. And as we prep for the session, it's been really impressive to talk to you, Albert. You obviously know a ton about your technology and where you're going and some of the technical challenges and how it applies to the cloud and frankly, the full end-to-end architecture. So I'm really excited to have you talk here at Google Cloud Next. Let's hop into the technology part and first start talking about some of the real challenges you face as you're building out this autonomous vehicle that's both a robot and a service wrapped around it. Do you want to start with the multidisciplinary part of it?
Yeah. So self-driving in itself is a very broad and varied problem. People pretty quickly jump to the AI ML part of it, and that's obviously a large part of what we do. But there's also a lot of traditional robotics algorithms, things like map building, things like simulation that all feed into that. Because we're so vertically integrated, on top of that, we build a custom vehicle. So we think of it as a large IoT device that's out in the world. So we have the challenges that come with that. And because we operate the service, we're also building an e-commerce and logistics platform. Now, those bring different challenges. Many especially on the self-driving side, of course, are research problems that don't have well-known solutions yet. Kind of develop it as you go. The other side, and people underestimate this often, for self-driving, even early on when you're in the development stage, you need a fairly large operations team for things like data labeling, for driving the fleet, maintaining the fleet of cars that we have. And for supporting all of those use cases, we also have to build a lot of custom tooling. So that's a little bit of our in-house SaaS solution for data labeling, fleet operation, and some other use cases.
It's great. It sounds like you have some real interesting technology problems to work on, and I'm certainly I guess, a curious person when it comes to this kind of stuff. Let's hop into some of the more lower level details and dig into the data management area a little bit. What does data management challenges kind of mean to you building these AI robots, autonomous robots?
So on the infrastructure side, data is really our largest challenge. We collect hundreds of terabytes of data every week from our vehicle on the fleet. And that quickly adds up to tens and hundreds of terabytes over time. The reason we need that data is both for simulation and for ML training. So as you know, ML, generally, the more data you can feed a model, the better and more accurate it will get. What's special for self-driving is even though you collect the data, you can't use all of it immediately. You're sort of looking for the needle in the haystack. So we need a lot of data to make sure that we cover all possible scenarios of things that we could possibly encounter on the road.
Yeah, so it's interesting about some of this data too. I realize that, I've seen some of these vehicles driving around, obviously kind of collecting real world data, but that's not the full data set. It sounds like you guys also, I'll say, create some synthetic data. Can you talk about that for a second?
Yes. So the data I've talked about so far mostly referred to the data that we collect by driving around, kind of the sensor input data. But when we run simulations, those reenact what happens on the real vehicle. So the output of the simulation is data that's very similar to what we collect on road. But now, because in simulation, we can run orders of magnitudes more miles than we can with our fleet on the road, we also get orders of magnitudes more data. So we both have the original data that we collected on road, and we have all this data that we synthetically can generated with simulation, which just adds to our data problems.
Yeah, I've really understood the number of scenarios that an autonomous vehicle could encounter on the road, particularly if you start to think about rolling it out worldwide. It's just incredible. So I can really appreciate why you're collecting tens or hundreds of terabytes a week now, and you're just going to have these massive stores of hundreds of petabytes over time. So it's a real challenge. And of course, data is great, but you have to do something with the data. So let's talk a little bit about GPUs and computing on the data. What are the challenges there?
Yes, like you said, having the data sit there is not all that useful. Once you have that amount of data, compute on it becomes pretty challenging. One thing that we found is for a lot of the sort of computations we do, they're best done on GPUs. That since GPUs are our best friends, very easy to explain. Of course, the ML side of it, people are very used to using GPUs for ML training, ML inference. We do that. We also use them for more traditional CUDA compute, a lot of geometric computations. In addition, we also do rendering, sort of what GPUs were originally built for, both for creating synthetic data, but also just for visualization so that people have an easier way to look at and understand the data. Now, I say GPUs are our best friends. That is true in a single instance. They're also a little bit difficult. Unlike GPUs, the state of maturity in terms of virtualization and sharing GPUs across workloads is not the same as it is for CPUs. So that's an ongoing challenge. The other thing is that because we do all of this compute and because it's so heavily relies on GPUs, our demand for GPUs is very large. It's also very bursty. Sometimes we want to run very large jobs and get to them very quickly. And that becomes challenging in itself because supply can be a problem for GPUs. So we spend a lot of effort to make sure that all the places where we use GPUs, we do that very efficiently. And we really don't have the GPUs sit around and wait for I/O or wait for CPUs to do their job.
Yeah, and I certainly appreciate, you talk about a job using hundreds or thousands of GPUs. Each GPU has like thousands of mini cores inside of it. So you have this massive, I'll call it kind of a supercomputer, trying to process these massive sets of data. So it's just really interesting to see, the challenges that exist at these areas. And we can hop forward and talk a little bit about how you, kind of address some of these challenges and some of the stuff you do in Google Cloud to basically run this stuff in production. So let's dive into the storage piece first. There's obviously a lot of different types of storage in Google Cloud. Can you talk a little bit about how and why you use some of these technologies?
Yes. So I mentioned early on sort of the amounts of data we have. Obviously, just managing that size becomes much easier in the cloud, where you have quick access and you don't have to buy hard drives as you collect more data. What makes it a little bit challenging is that we have multiple consumers for this data, and they have very different requirements, both in terms of access patterns, but also how long the data needs to stay around. So we've developed an in-house system that allows us to do very sophisticated lifecycle management and placement of that data. And that allows us to exploit the strengths of different storage systems that are available, both in cloud and outside. So for example, GCS is fantastic. If you just need capacity, you need it cheap, and you stream through your data at a moderate or large scale sequential fashion, you just need bandwidth. It's not so great when you have very high I/O rates, especially if that is random read. And for those things, we use file store or local SSDs. We also have some other places. Persistent disk is the best solution. And even though we talk a lot about cloud, some use cases still best solved with an on-prem storage system. For example, we have people that interactively work with data from the office. And oftentimes the best way to solve that is just put a storage system there, give them the minimum latency, and just sync it periodically to what's in the cloud.
Yeah, great. There's a lot of options, and it's good to appreciate which one to use in the right situation, because they all have different performance and cost points. And depending on the workload, one is definitely a better fit than the other. So it's important to just kind of understand these and map them. Now let's talk about talked about GPUs and some of the challenges on them. Let's talk about you have some use of containers and GKE. Why do you choose to use those? And how does your use of GPUs kind of manifest on Google Cloud?
Yeah, we are big fans of Kubernetes. We started on-prem with a Kubernetes cluster. The fact that we could use GKE made for a very smooth transition from on-prem to the cloud, because we can use the same Docker containers in both environments. Then when we look at cloud, again, it's a little bit similar to what I said about storage. Different workloads have different requirements. And the biggest difference is that we have some workloads that's base load that's always there, where we mostly care about availability. Think about any interactive task. An engineer submits a job, 30 minutes, they want a result back. It just has to always be available. And then there's other workloads where we know a job going to take multiple days. We just want to burst as much as we can and get the maximum capacity. Turns out cloud is actually a pretty good solution for both, but you have to be mindful of how you do it. So the way we have our environment set up is that we use a combination of committed machines and then preemptible VMs for those use cases where we really just need a large amount of compute for a bounded amount of time. One further thing to really adjust for the difference in workloads is also we use different instance types, sometimes custom instances, to make sure that we use sort of the right compute solution for the right problem.
Yeah, it's great. We obviously try to offer a wide range of instance types to kind of match your workloads, and it makes a lot of sense in that you use the CUDs to essentially buy the base and rent the peak. Is a term somebody told me in the past that makes a lot of sense to kind of manage your budget. Now, the other interesting thing is you said it's not just about the AI training piece. That's cool and interesting and an important thing, but the operations piece is a big part too, and maybe underappreciated by some folks. Can you talk a little bit about what scalable fleet operations mean to you and why cloud is interesting?
Yeah, so this goes back to the very beginning, where I talked both of us as a vertically integrated company, and also about needing operations in a fairly early stage in the company. Now, both of those need systems to support it. Things like remote management of the bot, telemetry, diagnosis of vehicles, but then also things on the business side, managing order flow and the general fleet assignment. Now, even early on, you need these things to be really reliable, because if that system is down for half a day, it might not impact any customers yet, but it means it's half a day that you lose on development because you can't drive the fleet. So cloud gives you that nice advantage that you have a very solid base infrastructure without having to have the administrative structure to support it. And then as you go into production, you also have a very smooth path where you can scale this system by just adding cloud resources to it rather than having to buy new servers and build up your own data center.
Yeah, so I can imagine because you're going to have these, this delivery service could be, scaled out to places around the world. The fact that cloud is kind of built out around the world gives you easy access points. And again, if you're going to monitor the fleet and do diagnostics, it just makes a lot of sense that it's kind of a natural fit to how the growth of your company is going to go. Let's spend a little time on the wisdom and lessons learned. So you've been building and running these systems for a while. I always tell people that wisdom is hard earned by smart people, kind of working hard over time. So let's jump in and hear a little bit of advice, and you can start with something that kind of makes a lot of sense from coming from somebody who works at Google Cloud. But why does going cloud native early resonate with you? Why is it a piece of advice that you would want to give to people?
Yes, so this one might surprise people because we're a fairly young company. I think people often assume that we're born in the cloud, that we're cloud native. But in the very early days, we started on-prem. And that also means that we ended up with a lot of these collection of services that's not very critical, that needs to be there, but it's low profile. And there's a big temptation when you then move to cloud to just do the simplest thing, which is spin up an instance in the cloud and put that service there. It turns out that you pretty quickly run into problems. So even systems that are very low profile, as the company grows, at some point they run into scaling problems. As you get more mature, you start to care more about security, access control. And doing that across the collection of different services becomes really difficult. Very similar for automation. So things like Terraform are amazing when you're in a cloud environment, but they don't mesh very well with having random one-off database servers that run on compute instances. So one thing that we learned was it's very good, even if it looks like overkill at the time, to look at these and move them to managed services early on, and then be able to address all of these problems that I mentioned earlier without having to do much work on a per service basis.
Yeah, it sounds like it's a little bit harder to do the modernization to move to the managed services, at the beginning, but it saves you some longer term tech debt. Is a term that I think a lot of folks understand. So let's talk about data, and the advice you have around how, what you've learned and how you would give advice for people on managing these large data sets in the cloud with so many different, kind of access needs and performance, workload matches, et cetera. How do you frame up your advice for data?
Yes, so I think anybody who's designed a large-scale system where performance matters to any degree knows that it's very important that you keep your compute and your data close to each other. Now, one thing that we learned as a corollary is compute is very easy to move, especially in cloud. You spin down one instance, you spin up a new one. That's not true for data, especially once you have large data sets. Moving data around becomes time-consuming and often expensive. It might actually seem to some people those problems go away in cloud because there is great networking, and you can access any storage system from anywhere. But doesn't 100% work because you still have the physical limits of latency between those systems. And of course, the commercial limits of having to egress if you have certain configurations of moving data around. So it's really important that you kind of think about where do I put my data so it's close to the computation that I want to do. And that means both geographically, but it also means thinking about what storage option that you want to use for different use cases. And storage options, they are used broadly. It's not just GCS versus file store. It's also, should this be in an object store, or should it be in a database, or should it be in a key value store? And making the right decisions there early on is key to having a healthy system that's easy to scale.
All right, great. So let's talk about the last topic for a quick second. And obviously GPUs, you mentioned they're your best friend, and they certainly have some challenges. talk a little bit about how compute capacity and cloud capacity is an important thing to think about and plan for.
Yes, one of my favorite topics. So simulation is an interesting problem in that it almost has no limits on parallelism. As many resources as you can give me, I can use to run my large simulation jobs faster. And that's very exciting when you first move into cloud, because you feel like cloud capacity is infinite. You pretty quickly learn that it's not. It's large, but it's not infinite. So especially when you want to run really large jobs, you have to understand, out of all the resources you need, which is the one that's going to run out. And then you have to design around this. So first off, you don't want to build a system that can scale much further than what you have in available resources. Probably waste some time there. And then you want to make sure that whatever your limiting resource is, you get maximum utilization of. And once you've done all that, so you've kind of reached the limit of what's available to you, you also want to work closely with Google, do some capacity planning, know when you need those resources, and then go to your support team and work together with them to make sure that when you need them, those resources are available to you.
Yeah, so this is a really interesting topic, and certainly I had a really smart colleague early in my career, say to me that designing large-scale systems and tuning and optimizing them is really a process of kind of pushing bottlenecks around the system. And it really resonates with the comment you made, Albert, about really understanding your bottleneck and planning around it. And it's important for the overall performance of the system is largely defined by the bottleneck in the system. So the better you can understand it and focus on it, the better your overall system will be designed. So just really great wisdom and lessons learned. I hope you've all enjoyed this topic. And lastly, there's also a lot of great content on the Google Cloud website. I've captured a couple links to some AI documentation, some of the compute accelerators, some general storage information, as well as some information on the storage transfer appliances, which we haven't spent too much time on, but are important in this use case if you think about moving data from some of these autonomous vehicles up to the cloud. So the last link is for the storage transfer service there. With that, I would like to have a huge thanks out to Albert for spending some time to record a session and share some of his insight and wisdom with us. So thank you so much, Albert.
Thanks, Brian. It's been great talking to you.
And thanks to all you out there in the audience. I hope this was a useful session for you. And I hope you enjoy the rest of the content at Google Cloud Next.